Hello, in this OpenGL tutorial we are going to show you how to set up OpenGL using GLFW as the provider for creating a render window, using GLW for loading in OpenGL extensions on a Windows machine and relatively linking it. Because we've got a video covering absolute linking, so feel free to check that out if you're interested in absolute linking, but this video will cover relative linking. So just a quick overview of what absolute and relative linking is. Absolute linking is if you create a project, you link up your libraries like GLFW, GLEW, anything else that you want to link, and when you link them up, you actually specifically put the directory they are in. So if they're in the C drive, like C:// whatever, and you would actually put the explicit directory. If you were to move the library files, you would have to update your Visual Studio project. But the great thing about this is there's only one instance of it and it's in one location. With relative linking, it's actually linked, well, relatively to your project. So you don't say it's on the C drive, you say relative to your project, it's in this folder. But we'll structure it in a way that you don't have duplicates as well. So it's a great method for transporting it from machine to machine. I prefer this method for development when you're developing stuff that doesn't have some sort of really good visual sort of editor that does all of the linking for you, like Unity or Unreal, for example. You install it, it just works. But if you do manual linking, I prefer relative for development. But if you are interested in absolute linking, feel free to check that video out. Okay, talked for long enough. Now, what we need to do is download GLFW and GLEW. As you can see, I've already got them. But to get them, just go to a web browser, type in GLFW, go to the glfw.org website. Don't click download here, because this will download the source files. We want the Windows binary. So go to download. Scroll down, Windows pre-compiled binaries. Just select the 32-bit Windows binaries. For development, I always recommend 32-bit. Simply, this allows you to ensure maximum compatibility. If you really know that you want 64-bit, maybe you need to use more than 3 gig of RAM, for example, for your application. But if you're on the fence and you're not sure, just stick with the 32-bit. Because if you're not sure about it, you want the 32-bit. So just click that. I've already got it downloaded. Next, you want to go to the GLEW website, and on here just select the binaries. This includes the 32-bit and 64-bit. We'll just be using obviously the 32 or the 64 depending on which version you've got. Again, not the source, the binaries. I've already got it downloaded. There will be links in the description to GLFW and GLEW, so you don't have to just memorize these links yourself. So once you've done that, next step is to create a folder wherever you want. And I'm going to create on the desktop. I'm going to call this OpenGL. Inside here, you want to create another folder called external libraries, and all of our libraries like GLFW, GLEW will reside in here. When you start linking up other stuff such as ASIM, for example, which you'll be doing later in this series, recommended to put it into sort of one external directory so you know it's separate to what you're actually coding. So in here, I'm going to place these once we've extracted them. So if you just extract them using something like WinRAR or 7-zip, anything should do. Do the same for GLEW as well. So the way I've extracted it, if I open GLFW, I've got another folder called GLFW. It's the folder that contains these files and folders is what I need. So I'm going to move that over. Now do the same for GLEW. So it's the folder that contains these files and folders. Move that over. And the one last step, this is an optional step, but I definitely recommend it. Rename it so it's just GLEW. Doesn't matter whether it's uppercase or lowercase. I prefer it uppercase. But the main reason I'm renaming it is when we're linking it, instead of typing out something like GLFW-321 Windows, whatever it was called, it's just easier this way. The other thing is, if at a later date you decide to update GLFW, maybe there's a bug fix in the next version, you can just easily replace the contents of the GLFW folder, for example, with the new version. If it's got, a name like 3.2.1 and the version you got is 3.2.2, it just looks a bit silly and confusing because it's the wrong version. And if you try and rename it, you need to relink it. Whereas if you just name it without a version, it's just good and it's ready to go. So this is all of our libraries downloaded. Now what we need to do is create a Visual Studio project, and let's open up Visual Studio. I recommend 2015. The 2017 is out at the moment. 2017 doesn't actually have binaries with a lot of frameworks out there, so 2015 is the recommended one for now. But once that's all been sorted, and if you want to use an old version or a new version, the process will essentially be the same. So click New Project, go to Visual C++, WinFade2 console application, and what you want to do, just name it something. I'm going to name it GL app. Click Browse, go to your folder that you created, just select the folder, click OK. You'll get this application wizard that pops up. Click Next, select Console Application, Empty Project, deselect Security Development Lifecycle. Now just click Finish. And we need to actually link up our code from GLFW, GLEW, and the libraries as well. So if I right click, go to Properties, there's one step we haven't done yet. I just wanted to skip that step so I can show you why that step is important. There should be a folder here called C/C++. It's not here, and it's not here until we specify essentially what sort of project we have, and that gets specified once we add a file. So if I click New Item, you want a .cpp file. I'm just going to call it main.cpp. We're going to code this up after, but now if we go back to our properties, as you can see, we've got C/C++ right here. In configuration, select all configurations so we can just configure it in one go for debug and release. And for the platform, either select WinFade2 or 64-bit, depending on which version you have downloaded the libraries for. I've downloaded 32-bit, hence why I got the WinFade2 selected. So we'll open up C++, go to General, Additional, Include Directories, click the drop down, click Edit, click New. You don't want to click the three dots because that's absolute linking. Do relative linking, you're going to do $solution dir, and this refers to the folder that contained our .sln file. So whenever we do something in here, so if you were to specify a folder, it'd be relative to wherever that is, so we can move it around and it's relatively linked. Because we want to go to the external libraries folder, we want to go back one. You just put .. go into external libraries / let's do GLFW first / I know it's include. So if I go into external libraries, GLFW, go to include, as you can see, we've got the code files in there. So now just copy and paste this to save some time onto another row, and just replace GLFW with GLEW. Again, if we go to the GLEW, this is where the code is. Click OK. That's the actual code files linked up. Now we need to link up the binary files, the libraries I should say. So go to Linker, General, Additional, Include Directories, click the drop down, click Edit, click New. You should already have it copied into the buffer. Just paste that into here. The only thing you need to change here, instead of include, we need to go into lib-vc 2015 / lib-vc 2015, click New. Sorry, there should be no include. I've got to get rid of that. And click New, paste that again, what you've got, change this to GLEW. It's slightly different for GLEW. It's a lib folder, then a release folder, then the version, the actual platform architecture that you're coding on, or you've downloaded the stuff for, so WinFade2. So it's lib / R and release, and then it was win32. Just to confirm, lib release win32, fantastic. Click OK, click apply. Let's go one more thing. We need to actually link up these .lib files now. So go to the drop down, click edit. Now in here, just type in OpenGL 32.lib. This isn't downloaded with GLFW or GLEW. It's built into Windows. And now on a new line, just type in GLFW. And I can never remember what the actual... I was already in GLEW, so I'll link this one up. So there's two here. You only need to link up the one. If you want regular linking, just link that one. If you want to statically link it, then link this one. Some of my videos have it linked statically. The code after you've set it up does not matter. The process is the same. So GLEW32.lib. And now for GLFW, lib VC 2015. It's GLFW3.lib. Don't need to deal with this one, just this one right here. So GLFW3.lib. Again, I would like to confirm got the right name. Click OK, apply, and that's it. So now what we're going to do is actually just start coding everything. So we can actually start coding our application. So hash include, going to put a simple IO stream here. We're going to have a hash include GL. As you can see, it's picked up the folders /GLEW. If you statically linked it, what you would need is a line before you include the GLEW header called hash define GLEW underscore static. But as we haven't statically linked it, we don't need this. I'm actually going to comment it out. Now we're going to do hash include GL, no, it should be the angle brackets, GLFW, GLFW3.h. And you might have noticed that by default it puts a backslash, and I choose to have a forward slash. Forward slash and backslash works fine. It's just from the old days on Windows, they'd actually used to impose that you have a backslash, but forward slash works fine now on Windows, but backslash doesn't work on Unix-based systems. So if you want to make your code cross-platform compatible, recommend always using forward slashes. That's just a simple reason. I'm going to say create some constant OpenGL integers, which will have the width of our window, and we can just easily update these values to make it dynamic. And we need to assign it. We can't just do 800. It's not defined. My bad. And put 600 or whatever you want. Put some empty lines so I can easily scroll up and down. Create the main entry point. So int main. And as usual, I always like to put the return line first, return exe underscore success, so I know it's done. And now we can start adding our GLFW and GLEW stuff. So GLFW init, so this will initialize GLFW. Now what we need to do is set the required options for GLFW, and they are in the form of window hints. So GLFW window hint. And the first one I'm going to set is the version. So GLFW underscore context underscore version major, comma 3. So this, along with the minor version, forms the OpenGL version. So if I change this to minor 3, so if this, let's say, was 0, for example, that would mean you are setting the OpenGL version to 3.0. So I'm going to have 3.3. You might want to do newer. That is fine. The reason we choose 3.3 is because after in 3.1, I believe the code, in 3, I believe the code was deprecated for the old immediate mode of OpenGL. Then I'm thinking like 3.1, they removed some of the stuff, but removed the actual code, so you can't use the old immediate mode. But since 3.3, the OpenGL version along with the shader version actually matches. So for 3.3, the OpenGL shader language version is also 3.3. So it just keeps things consistent and neat and tidy. But if you need a new feature, feel free to use something like 4.3. So 3.3. And now we're going to set another window hint. And the next window hint is going to be the actual OpenGL profile that we want to use. So GLFW underscore OpenGL profile. And the profile we're going to use is GLFW underscore OpenGL core profile. That's just, we just want the core profile. We don't want any sort of backwards compatibility profile. The core one is fine. OpenGL underscore core profile. So that's all good now. I'm actually going to close this so we've got a bit more room to work with. Now we're going to set another window hint, and this one is going to be the forward compatibility. So we're going to put GLFW underscore forward. Nice. OpenGL underscore forward compatibility. We'll set that to GL true, like so. So we just got the forward stuff done, and now we're just gonna, this is just another optional one, GLFW window hint, and this will be whether or not the window is resizable. I'm gonna set this to GL underscore false, but if you want it resizable, you would obviously just have true. So this error should disappear, as you can see. Now what we're going to do is create our GLFW window object. So GLFW window, going to call it asterisk window equals GLFW create window. And the first parameter that it takes is the width, so we've already got that specified. Then the next parameter you can guess is the height. Next parameter is the title of your application, which is essentially what appears at the top here. So I'm just going to say OpenGL test. Now the next parameter is, we don't need to deal with this for now, so just put null pointer. So null PTR. The final parameter, again, we don't need to deal with it, so just put null PTR. And that is it. To actually create it, what we want to do is a extra step for when we set the viewport. So we're going to get the actual size of our screen. So essentially, if we have high density displays, such as Mac with Retina displays, this is what this is essentially doing. This is what the next few lines of code is for. So we're going to do int screen width and screen height. I'm not going to set it to anything. We're going to do GLFW get frame buffer size, and we just specify the window along with the screen width, but we're not just specifying the variable, but a reference to the variable, because the actual width and height will get stored in there. Again, this is just for high density displays. The display that I'm actually running it on now is an ultra wide display. I've just sort of set the resolution so it's not ultra wide for YouTube, but this is in high density, whereas on a iMac, for example, the new Retina iMacs, it would look a quarter of the size if you don't do this, and on non-scaled stuff as well. I mean, on scale high density displays on Windows as well, so it's the same principle. So now that we've got the buffer size, we'll actually be using that a little later on when we create our viewport. So the next step is to make sure that GLFW has successfully initialized our window. So we're just going to do if null PTR equals window. That means it hasn't successfully initialized. We're going to do stdc out failed to create GLFW window, and it's going to do an std and line, and now we're going to put GLFW terminate, so terminate anything to do with GLFW, and just do return exit underscore failure. And now the next step is to just set the current context to the window, because we've assumed that's been created, so we can set the window to the current context. So GLFW make context current, and we just specify the window that we created at the top. Now what we need to do is just essentially enable GLEW. So GLEW experimental equals GL underscore true. You need to set this to true, so GLEW knows to use a modern approach to retrieving function pointers and extensions. Though it says experimental, ignore that. It's not the best thing that's named in GLEW. That's fine. You just want to always set this to true. Now we're going to initialize GLEW to, well, set up the OpenGL function pointers. So what we're going to do is if GLEW underscore OK is not equal to GLEW init, so we're going to actually initialize it inline. So it's going to try and initialize it here. If it's not equal to the OK command, then something's gone wrong. And if that is the case, we're going to do a std cout, and it's going to be failed to initialize GLEW. And now we're going to do an std inline and just do return exit underscore failure. And now we're going to set up the GL viewport. So we're going to do GL viewport, and we're going to set the coordinates like the top left, so 0, 0, and now the width and the height. We're not going to use the width and height variables. We're going to use the screen width and height, because this will be the actual resolution that we want to set it to. And now we're going to do while. So this is going to be our game loop, and this is what's going to be predominantly be running whilst the application is open. So while not GLFW window should close. So while the window isn't trying to close, specify the window that we're checking this on, then run this game loop. So when we try, after we've closed the window, it will go out of here and go into here. So first of all, we want to check for events. So GLFW poll events. This isn't a very extensive way. This isn't the final way of checking for events. There's more code to handle that, but we got separate videos covering that. This is just the setup stage. Now we would just render. So render, and it's going to do GL clear color. So this will just set almost like a background color. Set it to 0.2f, 0.2f. 0.3f. Again, it doesn't really matter, ranging between 0 and 1, 0 being fully off, 1 being fully on. Equivalent of 0 to 255, just normalize. So red, green, and blue. Set this to 0.3f, and then finally alpha value. Gonna have this fully visible. And now we just need to clear the contents of our screen. So GL clear, and you just need to specify GL underscore color buffer bit. So essentially what buffer you are clearing. And in between here is where you would draw OpenGL stuff. And we would now just put GLFW swap buffers window, and that's it. So if we run this, and let's see what we get. We get an error. Knew this error was going to appear. Didn't want to fix it. I didn't want to copy the file over till we've actually coded the application, and you can see this error. So what it's saying is the program can't start because it doesn't have a GLEW DLL. That's fine. If you go to GLEW, go to bin, release, select whatever platform you chose. So Win32 for me. Copy this GLEW32.dll into your project, into GL app where your code files are. And now if we rerun it, as you can see, it runs. We've got the command prompt, and we have our application as well. So that is fantastic. So just a little overview of this little area here. First of all, you always want to check for events / input. So if the users, let's say, clicking the left key, then you want to handle game logic. So let's say if the user clicking the left key, move the character left, for example, then you want to draw the new contents. And all of this is part of the render stage. So first of all, you want to clear it. This is just like an optional line because it just adds like that background color. You want to clear the contents, then draw OpenGL, which we'll be covering in a separate video, then just swap the buffers on the window. And that is it for setting up OpenGL using GLFW and GLEW on Windows using relative linking. If you have any questions, feel free to post them on our educational platform, sonarlearning.co.uk. There'll be a link in the description. Alongside that, there'll be links to GLEW and GLFW. If you like the video, please give it a thumbs up, hit that subscribe button and leave us a comment. And as usual, thank you for watching and I hope you have a great day.